Okay, I'm going to introduce a new and completely different concept that you might not have heard of. If you've heard of it, that's great. This is going to serve as a reminder for you. If not, don't worry, I've got you. So essentially, we're going to talk about gravitational potential. It's a very relatively new concept if you're studying this topic, and you must know what it's all about. So the gravitational force as we know it is attractive, and this means that the force acting on a mass will be negative, right? So it's very important for you to understand this. And what I mean by this is if you're at a specific point from the Earth, the force that you're going to be experiencing due to the Earth will just be negative, right? So you need to understand what form of work can exist, because a body is just going to move, right? If you jump up, you're going to find yourself falling down, right? So you're going to find yourself experiencing a force, moving a certain displacement, so work is done. Right, so we need to understand, what is that work that is being done? Does it have a special name? Why are we just doing work without us actually moving or doing anything? What's happening? In this video, we're going to explore that. Understanding why work done is positive. Why is it that the work that we do can be positive at times? So this is the typical work that you know. If a person experiences positive work, they would have experienced a positive force moving a certain displacement. So if you look at this illustration over here that I have, we have an attractive force over here. So it's a force that's trying to pull you towards the Earth. But if you happen to walk and move in this direction on your own, we can say you're doing positive work. You're using your own body to move against friction, against an attractive force, against something, and you're experiencing work, right? That's positive work. Okay. So in this above illustration, think of the person as being pulled by the attractive force, but then they move against it, so they're doing positive work. Okay. So we also have what is known as work done being zero, right? If you're doing no work at all, what are you doing? This is quite straightforward to understand. If a person doesn't use up any energy at all and experiences no displacement at all, we can safely say no work has been done. Okay. So if you just remain stationary, standing over there looking weird, we can say you're doing no work. Yeah. Why is work done negative? So there's a concept of negative work that we need to understand, right? So I don't really know if this is like formal, Cambridge lingo for you to use and say negative work. But in order for you to understand the gravitational potential, you have to understand this concept. Okay. Imagine if a person was being pulled by an attractive force, right? So you're sitting there and you so happen to just be pulled, right? You can safely say you've done no work. You're not doing anything, right? You're not using your own energy, but work is being done on your behalf. You're being dragged, right? So you can see this person over here, this little illustration that I gave you. This person is being dragged, right? So they're experiencing a displacement, but not because they are doing work, but because work is being done on them. So that implies if you experience a displacement without using your own energy, negative work has been done. Work has been done on your behalf to the extent that it's now negative. Okay, so you need to understand all these different facts that we've introduced if you really want to understand what gravitational potential actually is. We're going to start off moving from infinity. So the assumption starts from infinity. Now, don't be confused. What is infinity? What's going on? Think of infinity as a place far, far, far away, right? And if you want to move a mass from infinity, so if you want to move a mass from a place far, far away, which is over here, and you want to move it, right, where potential energy is zero, so we make an assumption that at infinity, potential energy is zero, right? There is no energy that you possess at infinity. You're just there, right? So any work that is now done moving away from infinity is actually negative work. Think about it, right? If the Earth is over here, okay, we're going to make an assumption. If the Earth is over here, so we're going to say Earth and infinity is over here, right? What kind of a force is going to pull this person who's just chilling at infinity? Okay, so you have this guy chilling at infinity, a very place far, far away. What kind of work do you think is going to happen to move this person? Negative work, right? Because the Earth is going to pull this person towards it. The Earth consists of negative forces, attractive forces, right? So work is always going to be done on you if you're in a gravitational field. The gravitational field will always pull you down, pull you towards it, do all of that. So you can now see that negative work will always be done. Gravitational potential is always negative, right? In a way. So the work that you do per unit mass, get this, the work that you do per unit mass in bringing a small test mass from infinity, in bringing a small test mass. So this is my test mass dummy. I'm going to call him Bob, right? Bob is over here. So the work done in bringing Bob from infinity, a place far, far away, to a specific point is what we call gravitational potential. What work are you doing? It's a negative work. What work are you doing to move Bob from infinity to that point. So this is that point, which is over here. So that's essentially what we mean by gravitational potential. What work do you do to move a unit mass from infinity to a defined specific point, right? So gravitational field is a new concept we're gonna introduce and give it this symbol phi, right? So the symbol phi and the units for gravitational potential are actually joules per kilogram. So that's what we mean by gravitational potential. What work do you do per unit mass as you bring a small test mass from infinity to a defined point, right? So that's all you need to know as we introduce gravitational potential. We're going to go and then calculate what it is, how do we calculate it, what's going on in the next video when we introduce and explain why it's actually negative, right? So like I've already sort of hinted a little bit, but essentially in this video, we're trying to introduce gravitational potential. Think of work as being done in three forms: positive work, negative work, zero work. Think of negative work as work being done on your behalf. Imagine infinity being a place far, far away. If you want to move a mass from infinity towards the Earth, attractive forces are going to pull that mass. So negative forces, negative work is going to be done. And that work that is done in moving a test mass is essentially gravitational potential.